All right, everybody, today's lesson is on literal equations and formulas. They're essentially the same things. Formulas are a form of literal equation. Literal equations, just in general, means an equation where each variable actually represents some particular value. Um, but for all intents and purposes, literal equations, formulas, they're the same thing. Now, the formulas that I'm showing here are not formulas you have to have memorized as of yet, but you should get used to some of these formulas. For example, after geometry, you should know the area of a rectangle is length times width. After Algebra 1, you should know the equation for the slope-intercept form of a line. Famous equation equals mc squared. If you had freshman physics, which most of you did, you should recognize this one that tells you the velocity of an object after you know its original velocity plus the acceleration times the time it's been accelerating. And this is also another physics formula that tells you how far you've traveled. If you know where you started, how fast you started at, and your acceleration and how long you've been traveling. Now, again, you don't have to memorize these formulas right now because we are just practicing manipulating these formulas. And what I mean by that is lots of times you'll be given a formula that says area is length times width, or whatever the formula is, and you need to find out what the length is. And so you would resolve this formula so it just tells you L is, and so we want to have it just reconfigured so that we can solve for a particular quantity or variable, if you will. Okay, so in your work that you're going to do today, it's not going to be, hey, what's the formula for the area of a square? Instead, it's going to be, here is the formula, solve it for this variable or this quantity. So let's take a look at a few examples of how we go about doing that. So here I've got that first formula, area equals length times width. We want to solve it for W. You have to remember we've been practicing for this past week quite a bit of PEMDAS, and you solved equations on Thursday and Friday. In solving literal equations or formulas for a variable is just like solving an equation. In this case, I want to solve for W, so you always want to identify what you're trying to solve for. Okay, I'm going to highlight him. Then recognize how it's connected to variables that are on its side of the equation and how they're connected. In this case, area is length times width. If I want to get W alone, which is what it means when it says solve for W, it means to isolate that W, get it by itself, I have to undo whatever it's connected with. In this case, it's connected with L by multiplication. So to undo multiplication, we use the inverse operation, which is division. And so I'll divide by L, and you can see right away we get L over L, which is just a 1. They cancel each other out. So the right-hand side becomes W, and the left-hand side becomes whatever it is, in this case A over L. And you've just solved that equation, or that formula, for W. Now in general, when they ask to solve for it, we're going to flip that around in this case. So it says the width of a rectangle would be equal to its area divided by its length. So just a one-step little problem. Let's get a little more complicated now. Here we have the equation for a line in slope-intercept form. We'll be covering that in the next few lessons. And we want to solve it for M. So let's go ahead, write the formula down. Let's highlight what we're solving for. Okay, so I want to get that M by itself. So let's look at what's connected to the M. We've got M times X plus B. Now, when you're working with PEMDAS, this order of operations, and you're solving for things, you have to work in opposite order. So you want to undo subtractions and additions first. So this is m times x plus b. I want to first undo this addition of the plus b. So we'll simply subtract that b from both sides. On the right hand side, those just cancel, giving us mx is all that's left over there. On the left hand side, remember we just talked about like terms. They have to be the same variable. Well, y and b are certainly not the same variable. So the only way we can express that is just by writing y minus b, like that. Now our last step, I'm still trying to get that m alone. Okay, it's m times x, so I'll undo that multiplication by dividing by the x. The highlighted variable is what I want to get by itself, so I don't want to divide by m. I want to get rid of that x. And x over x is just a 1. It just cancels out, leaving me with an m. And the left-hand side is whatever it is. Y minus b over x. Again, we'll flip that around. So it's the same expression. We're just using the mirror image of it, as it were. Okay. Let's look at another. This one looks a little bit more complicated. am equals m plus p, and we're solving for a. Well, this is going to be pretty easy, actually. Pause the video and see if you can think to yourself what you would do. I'll highlight the m. Oops, not the m. I'm solving for a. Look at how the a is connected to the m. You want the a alone, so what are you going to do? Well, you divide the left side by m, because that would just give you a 1a. And you have to do the same to the right. And you're done. Now, there is another another expression you could write for this, or another equation. You could break that fraction up as n over m plus p over m. Either of these are correct, though. So I would stop right here, but be aware that if you were taking a multiple choice test and that was one of the answers, you could separate that fraction using the common denominator. Couple more examples. This one's going to be one that frightens people just because we got fractions involved and because we've got a y in 2 different spots. So it's going to be tough to get that into 1y equals equation. Now there's several ways to do this. Whenever I'm dealing with fractions, whether it's a fraction on both sides or just a fraction on one side, the method I like to use is multiply that side by the denominator. So I'm going to take the right-hand side times y, which forces me to take the left-hand side times y. And by multiplying by the denominator, they cancel each other out, leaving me with just 1 plus 2y on the right-hand side and y times x on the left-hand side. Now I still have a problem that hasn't solved everything for me. If you look now, all it's done is put a y on the left and a y on the right. But now what I can do is get the y's on the same side. And to do that, I'm just going to subtract this 2y. And I chose to subtract the 2y because moving the 1 over to the left-hand side wouldn't do me any good. It wouldn't get the y's together. And so I've got yx minus 2y equals 1. Now this is a tough problem because we're going to pull out a tool you haven't used since the end of Algebra 1, which is called factoring. And in this case, because this first term has a y, this second term has a y in it, I can do what's called factoring, which is essentially the opposite of distributing. I can take a y and undistribute it, factor it, out of both of those terms. If I were to redistribute this y, I'd have y times x, that first term, and I'd have y times this negative 2, or negative 2y, that second term. I'm not sure why I put a y on the right-hand side, because that is incorrect. I haven't done anything to the right-hand side other than copy it down and leave it as a 1. But notice what's happened. By factoring out that y, I've taken an equation with two y's in it, the yx and the negative 2y, and now it's just a single y. And look at how that y is connected to x minus 2. It's y times x minus 2. Remember, I want that y alone. How's the y connected? With the x minus 2 through multiplication. How do I undo multiplication? I divide. Again to both sides. And so lastly I'm left with, these would just cancel, leaving me with the y on the left, and on the right hand side 1 over x minus 2. That right there is a very tough problem, but you can handle it. And look, as long as you do everything to both sides, you can't make a mistake. You can take a longer time to do it, but you know what? That's fine. Eventually you'll get there as long as you follow order of operations and don't do anything that's not quote-unquote mathematically legal. Here's our last. Y equals 9a minus 5b plus 7. We're going to solve this for a. Sorry. So here we go. Highlight that A or on your paper, put a square around it or underline it. Do something to notate to yourself, alright, what am I solving for? Well, let's look at how A is connected to everybody. It's multiplied by 9, then it's got this minus 5b plus 7. So let's undo this addition and subtraction first. So I'm going to add 5b to the right hand side. Those will knock each other out. And I'll add 5b to the left hand side. And that's going to give me y plus 5b. Can't combine them. Have to leave them separate. They are not like terms. Then, still looking at that a that I'm trying to get all by itself, I got to undo any addition or subtraction still, so I'm going to subtract that 7. Both sides. Those will cancel on the right, leaving me with 9a equals y plus 5b minus 7. And lastly, it's 9 times a, so I'm going to divide by 9 on both sides. 9 over 9 is just a 1. A equals y plus 5b minus 7 over 9. I'll write it up here so it's cleaner, and I'll reverse it. Now, all the problems aren't as tough as these last two that I did, but the last two are Algebra 2 level. The first several problems should be Algebra 1 level to get you warmed up, then they get a little tougher, and finally end with really tough problems. So make sure you practice these. And then on Tuesday, when we meet in person, you can ask questions and we can look at them and hopefully help you understand them a little bit better. And that's it. Go ahead, do the homework and get after it.